Just a refresher from yesterday, we talked about Pythagorean identities, which are different trigonometric identities that we can use to help us solve different equations that we can't solve using our normal methods like a GCF or like a factoring. There are ways of simplifying it so where we can get it into that GCF or we can get it into the U substitution, we can be able to solve for our answers. And so if you remember, we were able to take our original ones and we were able to change them a little bit to make them a little bit nicer for us to work with as we continue. And so we're going to be working on the back of the paper that we had yesterday. And so once again, you don't have to have these first three memorized, but the other forms of them, if you want to use those, you'll have to be able to know how to find those or how to work to get those. But these three, the sine squared plus cosine squared equals 1, and those like that, those will be given to you. And so if you remember, we want to use these trig identities when we tend to have more than just one trigonometric equation. So we have sine squared and cosine squared in this equation. So what looks like a good trig identity that we might want to implement into our equation to be able to make it easier and to get it into just one equation? Or just one trig function? Thomas? Yeah, so we want to use sine squared plus cosine squared, and more specifically, we want to get this cosine squared. We want to turn cosine squared into sine squared. So you can flip back to the other side of your paper, and we can look, and we have cosine squared equals 1 minus sine squared. And this one has cosine by itself, so that seems like a good equation that we should use to be able to help us get this equation just in terms of sine. And so we'll have sine squared theta minus sine of theta, and then we're changing cosine squared theta, and that's going to be 1 minus sine squared. Oh, I lost my theta. Theta. And if you don't remember how we came up with these, we took our original equation, which was sine squared x plus cosine squared x equals 1, and then we just subtracted cosine over. And we are left with cosine squared x equals 1 minus sine squared x. So all we did was we took this cosine squared here, and we substituted it in for this cosine. Or we took what cosine equals, and we substituted it in. And so we know cosine equals 1 minus sine squared. So we changed our cosine into 1 minus sine squared. And now we have our whole thing into terms of sine. And now we can solve using one of our normal methods that we should know. So what should be our first step to get, or to be able to solve? Gracie is going like this in the back, so I assume she needs to get everything over to one side. And so we're going to subtract by 1, and we're going to add a sine squared theta to get all of our terms on one side of our equation. And so we have plus sine squared theta, and we have a minus 1. And so we now have a 2 sine squared theta, because we have sine squared plus sine squared is 2 sine squared, and minus sine theta, and then we had a minus 1. And this was all equal to 0 on our other side now, because we got all our terms on one side. And now that we have our equation set to 0, what looks like the next step we should try? We want to do a U substitution. So we don't have a GCF, so we're going to go straight to our U substitution. And so we're going to let U equals sine of theta, because that's our trigonometric function in this one. And so we have 2 U squared minus U minus 1 equals 0. Yes. I lost my thing. Okay. Come on. Okay. So now we have just our u set equal to 0. So we can factor this using whatever method you're used to. So we'll use the slide divide and bottoms up on the screen, but you can use whatever method you're good with. So the first thing we're going to do is slide, and so we have u squared minus u minus 2 equals 0. And now we're going to factor. The factors are 2 are going to be 2 and 1, and we have a negative 1, and so we're going to have a negative 2 and a positive 1, and this is all equal to 0. And this is probably kind of boring to you at this point because we've been working with this a lot, and so we'll set both of these equal to 0. And then we'll solve, and we have u equals 2, and u equals negative 1, and this was because we minused 1, and we added 2. And now we have to remember, now that we have u by itself, we have to remember, what did we make u in the beginning? Sine. And we said u was sine. Good job, Ethan. And so we're going to now put sine back into the equation. And so I was just recently pointed out that I forgot to divide by 2. And so this is divided by 2. And this is divided by 2 because after we slide, we needed to divide. And so that changes these parts of our problem. And so we should have 2 divided by 2 is going to be minus 1, which is going to let u equal 1. And this is going to be plus 1/2, which is going to let u equal negative 1/2. And now that we have u equal to the correct part, we can substitute sine back into the equation for u. And so we have sine of theta equals 1, and we have sine of theta equals negative 1/2. And so now we need to think, where on our unit circle does sine equal 1?
3 pi over 2.
Pi over 2. And because pi over 2 doesn't have a partner on our unit circle, we'll have to go a whole circumference of our unit circle to get back to pi over 2, to get back to a coterminal length. So we're going to add 2 pi k to get the general solution, or the general formula for all the solutions on this problem. And now, when does sine equal negative 1/2? 5 pi 6?
7 pi over 6.
7 pi over 6. 5 pi over 6 is in the second quadrant, which sine's positive in the second.
And 11 pi over 6.
So 7 pi over 6 and 11 pi. That's a pi, I promise. And so 7 pi over 6 is, you don't have to be super specific as long as you just know the general area. And then 11 pi over 6. And do these make a diameter? No. So what are we going to add to the end of each of our each of our angles? What was that, Emma? 2 pi k. 7 pi over 6 plus 2 pi k and 11 pi over 6. And so your answers are all these solutions. Sorry. Should have asked for thumbs up. You're okay. It's my fault. Okay, so we have cotangent of a, or cotangent squared of a plus 3 equals 3 cosecant of a. And so we have our equation in terms of cotangent and secant, or cosecant. So which formula should we use to get all of our trig functions into one function?
1 plus cotangent squared equals cosecant.
Alright, we're going to use 1 plus cotangent squared equals cosecant squared.
Change the variables too.
So the variables, they don't matter. You can use theta, you can use x, you can use a big capital A for angle. It doesn't matter. As long as you're just consistent through your variables, we don't care. And so, how should we use this trig identity to help us solve cotangent of a squared plus 3? What should we get by itself in the trig identity that we have in our original equation? We have a cotangent squared. So we can change our trig identity to make it look, or to get cotangent squared by itself. So we subtract a 1, we have cotangent squared of x equals cosecant of x squared minus 1. And so now we have cotangent squared by itself. And we can plug cosecant squared minus 1 into our original equation. So now we have cosecant of a squared minus 1. That's what we replaced cotangent as. Plus 3 equals 3 cosecant of a. And if you really wanted to, you could try to change cosecant and get it all in terms of cotangent, but then you're going to get a square root, and that's probably not the best idea. So because we have a cotangent squared in our original equation, that's why we wanted to get a cotangent squared from our trig identity and use that for our substitution.
Sorry, what does that say?
Cosecant of a minus 1. And so now we want to simplify, and like Gracie, we want to get all of our terms to the other side by themselves, or all the terms to the other side, and get 0 on one side. So we have cosecant squared of a. Nope. That's not what I want. Cosecant of a squared, and then negative 1 plus 3 is going to be plus 2, and this is equal to 3 cosecant of a. And now we're going to subtract 3 cosecant of a to get it to all the same side and get all our terms. It's a plus 2. Sorry. My line didn't make it all the way across, so I had to draw a second one. So we had a cosecant squared minus 1 plus 3, and so we have a plus 2.
I'm sorry.
It's okay. It's a 2-hour delay, I understand. And so we have cosecant squared of a minus 3 cosecant of a. I'm writing it in descending order because that's how we tend to write these, just to make it look familiar to us. This is all equal to 1, or 0. So now we want to use our u substitution to make it more familiar to us so we can solve for our angle. And so I'm going to say let u equal cosecant of a. And so every time I see a cosecant of a, that's what my u is going to be. So I have u squared minus 3, 3u plus 2 equals 0. So every time I had a cosecant, I just change it for u. And now this one looks a little bit different from some of the other ones that we've done. So maybe we'll get something new for once, because I know we get the same factors that we tend to get. And so we have u and u, and when we factor, our factors of 2 are just going to be 1 and 2, so we don't really have much choice. And then we have a negative 3, so it's going to be a negative 1 and negative 2 combined to get negative 3, and multiply to get positive 2. And now we can set both of these equal to 0, so we have u minus 1 equals 0, and u minus 2 equals 0. And now we need to get u by itself. So we add 1, and we add 2, and we have u equals 1, and u equals 2. Now we have to look back at the top and remember, what did we make u in the beginning of our problem? We said let u equal cosecant of a. So now cosecant of a is coming back in, and that's going to be where our u was. Cosecant of a equals 1. Cosecant of a equals 2. And I don't know about you guys, but I don't have cosecant memorized, so whenever I see cosecant, I try to flip it and put it in terms of sine. And so it's sine of a. I'm going to take the reciprocal 1, which is just 1 over 1, which is still 1. So we have sine of a equals 1, and then sine of a equals the reciprocal of 2, which is going to be 1/2. So when a sine a, or when a sine is a, when of sine of a is equal to 1? Pi over 2, right? And then we already did pi over 2, so we know it's going to be plus 2 pi k for our solution for all of the answers, or our formula for all the solutions. And then when is sine 1/2? Pi over 6 and 5 pi over 6. And we can look on our unit circle. We can just make a crude sketch. We know pi over 6 is here-ish, 5 pi over 6 is here-ish. They're not going to create a diameter, even if I were to draw it through my center. And so we're going to add 2 pi k. And these are also the formulas for all the solutions. So we have one more problem that we can use this trig identity for. And if we look, we actually look at it first. We have this fraction, and this fraction might seem kind of intimidating at first. And so to make this problem seem less intimidating, we're going to get rid of this fraction. And so I'm going to multiply my whole equation by 2. So I'm going to multiply this side by 2 and this side by 2. But I'm going to rewrite it a little bit nicer so we can actually see what we're doing here. So we have 2 times tangent squared of theta. And then we have 2 times 3 over 2 secant theta. And so 2 times tangent squared of theta, that's just going to say 2 tangent squared of theta. But then 2 times 3 over 2. Yes.
By 2. Just the bottom of the
So because we have a denominator of 2 here, by multiplying 2 times 3 over 2, we're going to be left with just 3 because our 2's are going to cancel out.
Okay.
And so we're left with 3 secant of theta. And that way we can get rid of this fraction, which will make, in the end, this factoring a little bit easier for us. And so now we have our equation in terms of just tangent squareds and secant. So which trig identity looks like the good or a good one or the best one for us to use? Or which trig identity has tangent squareds and secant squareds in it? Our tangent squared plus 1 equals secant squared. And what part of this equation do we have, or what part of this trig identity do we have in our equation? Tangent squared. So we're going to turn this trig identity into just tangent squared. So we have tangent squared of x plus 1 equals secant squared of x. And so to get it just as tangent squared, we can subtract 1, and so we know tangent squared of x equals secant squared of x minus 1. And so now we can take this secant squared minus 1, and we can replace all of our tangent squareds with secant squared minus 1. That's supposed to be the same thing, but it doesn't look like it. And so now we have our 2, which is still going to stay there, but our tangent squared is now replaced with secant squared minus 1. Theta. And this is equal to 3 secant theta. So now that we have our whole equation in terms of secant, we can try to get all of our terms on one side and set it equal to 0 so we can factor. So we can distribute this 2 into our problem, and we have 2 secant squared of theta minus 2, and this is equal to 3 secant of theta. And now we can get all of our secants on one side. My 3's are horrendous today. 3 secant of theta minus 3 secant of theta. And so we're left with 2 secant of theta squared minus 3 secant of theta minus 2 equals 0. And now we want to get rid of our secants, so it makes it a little bit easier for us to read and be able to factor. If you can do it with the secant still in it, you're fine, and that's good for you. You're better than the rest of us. So we're going to let u equal secant of theta. So every time I see a secant, I'm going to turn it into u. And so I have 2 u squared minus 3u minus 2 equals 0. And now we can use our slide divide. First we're going to slide, and we have u squared minus 3u minus 4 equals 0. And we can factor. And we can think, what are some factors of 4? We have 1 and 4, and then we have 2 and 2. And which of these factors are going to be able to combine to get 3 or negative 3? 1 and 4. So we can take a negative 4 and a positive 1 to get our 3. And then now after we slid, we have to divide. So we're going to divide by 2 because that's what we slid with. I'm sorry. And so we have u minus 2 equals u plus 1/2 equals 0. And now we can just set each of these equal to 0. So 2 is 0 and u plus 1/2 equals 0. And we can solve for u, which u equals 2, u equals negative 1/2. And then we would put our equation back into secant and solve for it. And so we have secant theta equals 2, secant of theta equals 1/2. Cool. And just like cosine, I don't know how to solve, or I don't have secant memorized, or just like cosecant, I don't have secant memorized, so I'm going to turn everything into sine, or cosine. And so I have cosine of theta equals 1/2, cosine of theta equals 2, negative 1/2, so negative 2. And cosine of theta is equal to, oh wait, is it here negative?
No, right.
Alright, so cosine of theta is equal to 1/2 at pi over 6 and 11 pi over 6. And like we saw before, these do not create a diameter on a unit circle. And so we get plus 2 pi k plus 2 pi. And so we sort of got cut off on time here. And so we're going to go back, and actually I realized I messed this up a little bit. So let's go back to the secant equals 2, and the secant equals negative 1/2. And so I don't have secant memorized, so I'm going to change secant into cosine. And so every time I see secant, it's the reciprocal is cosine, so it's cosine of theta equals the reciprocal of 2, which is 1/2. And then cosine of theta is the reciprocal of negative 1/2, or cosine of theta equals the reciprocal of negative 1/2, which is going to be negative 2. And now when is cosine of theta equal to 1/2? We think on the unit circle it's pi over 3, 2 pi over 3. And so on our unit circle, we have pi over 3 and 2 pi over 3, and these do not create a diameter. And so we take both of our angles, we add 2 pi k. This is the general solution, or general formula for all these solutions. And now we have, when is cosine of theta equal to negative 2? And if you're trying to rack your brain on your unit circle, it doesn't. So you can say no solution, or you can just leave it blank.